Solving Inequalities Graphically with Adam Maths Tutor. Here are the beginner questions, some of the easier questions that you're likely to find on this topic. Solving inequalities graphically involves plotting the inequality on a graph and identifying the region that satisfies the inequality. To do this, we can first rewrite the inequalities as equations. For example, x is less than 2. We can think of as the equation x equals 2. We can then plot the equation. X equals 2 will cut through the x-axis at the point 2, shown here. Next, we need to look at the inequality sign and identify the region that satisfies the inequality. Since x has to be less than 2, values less than 2 are everything to the left-hand side of this line. One of the other things to consider is if the inequality symbol is strict or inclusive. Inclusive means it includes the number, and strict means it doesn't. In this case, it doesn't include 2, so we need to use a dashed or dotted line rather than a solid line. We need to shade the region that satisfies both of the inequalities at the same time, so I'll need to consider the second inequality before moving on to the next question. We can think of this as the equation y equals a half of x minus 1, and there's two ways of plotting this. We can either use our knowledge of the y-intercept and the gradient, knowing that this line cuts through the y-axis at -1, and a gradient of a half means for every 1 to the right, I'm going a half up, so another 1 to the right and a half up. Once you have a couple of points, you can draw a straight line between them. Alternatively, you can use a table of values, and just using three x values such as 0, 1 and 2, whilst finding the corresponding y values. When x is 0, half of 0, take away 1, would be -1. When x is 1, half of 1 is 0.5, take away 1 is -0.5. And when x is 2, half of 2 is 1, take away 1 is 0. Then we can plot these three coordinates and use these to draw my straight line instead. Since the inequality symbol is inclusive, this would be a solid line rather than a dashed or dotted line. And since y is greater than, I'm looking for all of my values above the drawn line. Therefore, my region that needs to be shaded to satisfy both inequalities will be the region shown here. They've asked us to label this with the letter R. On to the next question. Notice the regions have already been drawn, and they've asked us to write down the two inequalities that define the unshaded region. In most cases, they will ask you to identify the shaded region, but we just need to make sure we read the question properly and prepare ourselves for the fact that they could, if they wanted to, ask for the unshaded region. Starting with this line, we can use 2 points that go through the corners of squares to help identify the gradient of the line. I'm going to pick these two here. Going from left to right, this is a rise of -4, going down by 4, and then moving to the right by 1, which is positive. Therefore, y is equal to, the gradient is -4, and the y-intercept, we can see it cuts through -1 on the y-axis. Since the line is dotted or dashed, this is a strict inequality which is not inclusive. And since the unshaded region falls to the left-hand side of this dotted line, that would be less than, since it's below the dotted line. The best way to identify whether this is above or below the line is to imagine this is a ladder, and if the ladder was to fall down, what would be below the ladder and what would be on top of the ladder? If this ladder was to slip and fall, it would fall to the left-hand side, meaning everything to the left is below or underneath, and therefore less than. On to the other line, slightly easier. It just goes through the x-axis, which is considered y equals 0. The unshaded region is below this line, again therefore being less than, and since it's a dotted or a dashed line, it's strict and not inclusive, so will therefore just be y is less than 0. On to the intermediate questions with an increase in difficulty. On the grid, we need to shade the region that satisfies all of these inequalities with the addition of a third one. And again, we need to label the region R. Starting with the first one, x is less than 3. Considering the equation x equals 3, we'll go through the x-axis at 3. And since the symbol is strictly, it'll be a dotted or dashed line. The region is when x is less than 3, so will be everything to the left-hand side of 3. For the next one, we'll consider when y is equal to -2. This will go through the y-axis at -2. The inequality symbol is strictly, so will be a dashed line, and since it's values for y that are greater than -2, it will be the region above the dashed line. And the last one we'll consider y equals 2x minus 1, using a table of values and finding the corresponding y values when x is equal to 0, 1 and 2. When x is 0, 2 lots of 0 take away 1 is negative 1. When x is 1, 2 lots of 1 is 2, take away 1 is 1. And when x is 2, 2 lots of 2 is 4, take away 1 is 3. Plotting these three coordinates, 0, negative 1, 1, 1, and 2, 3, and connecting with a straight line. Since the inequality symbol is inclusive, it will be a solid line, and I'm looking for values of y that are less than or equal to 2x minus 1, so I'll need to shade everything that's below the drawn line, meaning I'll be left with this region enclosed by the triangle, which I'll label as R. For the next question, we need to write down the three inequalities that define the shaded region. I'll start off with this line, a vertical line going through negative 2, and it's a solid line, which would have the equation x equals negative 2. Since the shaded region is to the right hand side and a value is greater than this, along with a solid line which is inclusive, it will be when x is greater than or equal to negative 2. The line coloured green has a run of 2 and a rise of 1, so the gradient is a half. Y equals a half x, and the y-intercept is positive 1. Since the shaded region is below this line, and it is a solid line, which is inclusive, it will be when y is less than or equal to a half of x plus 1. And lastly, the line coloured blue has a rise of 1 and a run of 1, meaning the gradient is 1. It also goes through the origin, meaning that y is equal to x. And since the shaded region is above this line, and it is a solid line, it will be when y is greater than or equal to x. On to the advanced questions, some of the trickier questions that you're likely to find on this topic. It will be easier to plot these lines if we have them in the form of y equals mx plus c. So this first one can be written as y is greater than or equal to, and adding x to both sides would give us x minus 1 on the right hand side. Using the method of the y-intercept and the gradient, I know it cuts through the y-axis at negative 1, and the gradient is 1, so for every 1 across, it will go 1 up. Let's use that to plot a couple of points before connecting with a straight line. We can keep this as a solid line since the inequality symbol is inclusive, and we're looking to shade above this line since y is greater than or equal to it. On to the next one. We can add 2y to both sides and subtract x. Therefore 2y is less than or equal to negative x plus 6. And then dividing through by 2 to get this in the form of y is less than or equal to negative a half of x plus 3. It cuts through the y-axis at positive 3. And since the gradient is negative a half, for every 1 across, it will go a half down. So continuing this trend to map out a couple of points before connecting with a straight line. The inequality symbol is inclusive, so we can keep this as a solid line. And we're looking for when y is less than or equal to, so it would be everything below the blue line, represented by this region here when considering both inequalities. And for the last one, when x is greater than negative 3, x equals negative 3 is represented by this line. It's strict, not inclusive, so I'll use a dashed line, and I'm looking for when x is greater than negative 3, which would be everything to the right hand side of the dashed line, and will be represented by this region when considering all three inequalities. I'll label this with the letter R. On to the next question. Write down the three inequalities that define the shaded region, starting with this horizontal line, which cuts through the y-axis at 4, which is the equation y equals 4. Since the shaded region is below the line, and it's a solid line, it will be when y is less than or equal to 4. This line highlighted green has a rise of 2 and a run of 3. Therefore the gradient is 2 over 3. So y is equal to 2/3 of x, and the y-intercept is 1. The shaded region is above the line, and it is a solid line, so it will be when y is greater than or equal to this. Lastly, the blue line has a rise of negative 2 and a run of 1. Therefore the gradient is negative 2, and y is equal to negative 2x with a y-intercept of positive 2. Since the shaded region is above the blue line, and it is a solid line, it will be when y is greater than or equal to negative 2x plus 2. Therefore the shaded region is defined by these three inequalities. Here's a question that I've completed earlier. Here's a question that I've completed It appears as though I've made some mistakes. Pause the video and see if you can spot what they are before writing some corrections in the comments below.
Thanks for watching. If you found that video useful, don't forget to hit the like button and leave a comment. If you're struggling with topics or finding maths difficult, subscribe and turn on notifications to receive regular updates about new video tutorials and other useful content. You can visit and follow all of my socials by clicking the links in the description below.